Okay, it's John Black again. I noticed that when I get close to the microphone or the camera, it's just terrible with the audio. I'm going to try to not talk loud or talk close to the camera. Hopefully that'll help. But let's talk about this global warming again. We're almost done with it, thank God, although there's probably going to be 2 more videos about it. But the last video will be me actually prove. So far all I'm doing is proving them wrong. I want to prove me right, and I'm going to do that here soon. But let's talk about these first 3 blue things. Carbon dioxide is increasing in the atmosphere. Almost all this carbon dioxide increase is man-made. And temperature has risen about 1 degree since 1850, over 130 years ago, or 125 years ago or something. Out of that time period, it's moved up. I'm saying 1 degree. It's been this much for Celsius, this much for Fahrenheit. It's just easier just to say 1 degree. Now, this is the part, the red part, is where people do not agree with. You got some people agree, some don't. I say increase in temperature is not due to CO2 increase. They say it is. I say temperature increase is mostly caused by nature. They say it's man-made. I say all changes are beneficial. They say that the changes are non-beneficial. And what's funny is we all agree that this warming trend started 300 years ago, and the warming took us out of the little ice age. Because we've had an ice age for the last 2 million years at least, and the last 10,000 years it's been the coldest, and the last part of that ice age, it's been the coldest. There's a part called the Little Ice Age, which is like 10,000 years or something. And this Little Ice Age is the coldest of all the ice ages of the last 2 million years. And we are just coming out of it. And all the other ice ages that we've had so far, we're basically colder than that right now. Like every time that we have a dark age, where everything is terrible, it's because we dipped down into a temperature that is so cold that we didn't have as many plants and blah, blah, blah. But those times were actually warmer than it is right now, believe it or not. But anyways, here's a chart, okay? You got CO2 going up and down, and you got years going that way, right? And it goes back 8,000 years. Now look at this as the temperature, and the green is the carbon dioxide. You can clearly see the carbon dioxide has a trend of going upwards, and the temperature has a trend of going downwards. Even though they're spiked going up and down, you know what I mean? They're steadily going down. The up and downs are going down, and the up and downs are going up on the carbon dioxide. That's opposite, and that's for the last 8,000 years. Okay, the last 8,000 years. All right. So that says that they're liars. Okay. Now look at this here. This is a chart right here. It's got temperature instead of carbon dioxide, and it's got years. Okay, going back 1,000 years. This went back 8,000 years. This went back only 1,000 years. So if you look like this right here, right? This dip and then goes back up. That's this. It goes dips, and then it goes to the ice age. This right here would be the little ice age. This right here would be the little ice age. And this is where we are right here coming up. See how there's a little dip, and it comes back up. Dip, comes back up. This is that right here, okay? First, because here's a 1,000-year mark. So come up, and you have right here, if you be this part right here. Now, the CO2 again, would be the last 1,000 years. That'd be right from here, say. So this line here is this line right here, okay? You can see that they don't, all of a sudden it got colder, colder, colder going down to the little ice age, and you can see carbon dioxide pretty much stayed the same, okay? And then, yes, it does go up, and the temperature goes up. But I want you to look at something. I want you to realize something. What happened first? Did the carbon dioxide go up, causing the atmosphere to heat up? Or did the temperature rise first, and that causes the oceans to boil a little bit? And boil, I mean relative. I don't mean boil like 212 degrees Fahrenheit. I mean it just got hotter. And the hotter a liquid gets, the less it can hold gases. And the hotter it gets, more CO2 comes out of the ocean, okay? And it goes into the atmosphere. So let's look at the chart, and you tell me which happened first. Was it the CO2 that made it get hotter? Because I'm looking at it and I'm seeing that the CO2 wasn't really going up till about right here, about 1,000 years ago. But yet the trend of the temperature going up was about 1,600 years ago. You can plainly see that the temperature was caused the carbon dioxide. And don't get me wrong, this last bit of it, this last line or whatever, that's us putting carbon dioxide. We are putting carbon dioxide in and raising it up. But you can see that it does not correlate, okay? If anything, it correlates to the fact that when the Earth heats up, you get rid of CO2 and put it into the atmosphere. It is not the other way around, okay? And now, I'm going to go to this right here, this chart. Okay, that's not even a chart. That's just me doing an up and down lines, okay? But I want you to see over the last, 1,000 years, okay? Because I didn't make this right here would be actually going up and down too, right? It's not going to be a smooth, exact whatever. You know what I mean? It will go up and down, just like over here, you know what I mean? I just didn't write it that way because I'm tired of it. Was just easier. But if you overlap, like say the last 1,000 years or whatever, over temperature and carbon dioxide, this is what you will find. Just like this right here. Just like this. The temperature comes first and goes up, and then the carbon dioxide comes in. And I admit, this is 1,000 years from here over. We're only been 200 years, where we were doing stuff, putting carbon dioxide in the atmosphere. But you can plainly see, I didn't do the chart and I didn't look it up because it's been a long time and I'm tired of looking up charts. But you will notice that they do overlap over the last 1,000 years or so. The carbon dioxide and the heat, they do correlate, and it will look just like this. Okay, I didn't do the exact lines or whatever, but they go up and down, up and down, up and down, right? And you have your red and your green, and they almost overlap. They're about 500 years off from each other. Like this red line right here compared to that green line, the red happens, and then the green happens 500 years later, because the years go this way, right? On any chart, years that way. So, what does that tell you? And I'm saying and that's what kills me about the climate people, because they just pick a little tiny part of the CO2 and the temperature overlapping on each other, and they act like they just pull this little part right here, this part at the end. Basically, that's what they did. They part this part, and they took this part, and they stretch it out, right? They stretch it out. If you stretch it out, you're going to see more detail or whatever. It wouldn't just be a line up and a line up. These would be jiggly up, you just pull it out. Just like if you took this, like this is 1,000 years. What if it was turned into 1,000,000 years? And you had to do the opposite. Instead of pulling it out, you condense it together so it could fit into there. This line right here would just be a dot. There would be no up and downs. It would only just be a little tiny dot. And that's why it's a little tiny dot right now, basically just a line. But if you pull it out, If you pull it out and stretch it out, you'll have more detail. And this is the type of detail that you would have. You would up and down, up and down, up and down. And they will show you that and say, look, CO2 and what's funny is they will show you the chart sometimes. They will be like, look, CO2 and whatever corresponds, even though they're just showing you a little tiny part of fraction of history, only the last 1,000 years. And yeah, look, it looks exactly the more there's CO2. But if you look at it, the green part happens 500 years after the red part happens, meaning the temperature rises. Then 500 years later, you have build up of the carbon dioxide starts going up. Why? Because it's getting the CO2 to come out of the ocean. You know what I mean? It doesn't happen overnight. You can plainly see the carbon dioxide always follows after. And that happens all the way up until 300 years ago, right? And then the temperature starts going up. But our CO2, before this, right, we weren't making any CO2. And you can see plainly it was going up and down, up and down, up and down. But when it gets to this point, our CO2 should have been right here, right? Should start going down, just like all the other times, right? But we're making carbon dioxide, so you can see it shoots. And it does. It really shoots up past where the temperature is. But the thing about that is, you can look and see the temperature has not gone up. As a matter of fact, it looks like it's going to go down. It's ready to do its little curve going back down. It's flattening out, just like over here. Come up, flatten out, go down, flatten out, go on. You can see right here plainly. It is going to start going down. It is flattened out, and it is not going up like there's a carbon dioxide up here. Why isn't the temperature up here? Because it doesn't matter if you dump it. 0.0 is the same as 0, just like 0.04 is the same as 0. So if you have 0.04% carbon dioxide in the air, it's like having nothing in it. It doesn't do anything to affect the temperature at all. Not at all. I mean, if you're going down to like 1,000th of a degree or something, okay, I'll whatever. Or you have 10% carbon dioxide in the atmosphere or more, okay, yeah, then I believe you. But when you have 0.0 of something, like 0.0 carbon dioxide, guess what? That's the same as having 0 carbon dioxide when it comes to green gas effects, okay? And they will show you, even the crazies will show you this, and everyone in the audience is like, yeah, it makes sense that the temperature would come up first and then the CO2. So obviously it has to be the CO2 affecting the temperature. Does that make sense? And everyone agrees, even though it's crazy. It's crazy. Okay, so let's see what time it is. Okay, I got 2 more minutes. But when I come back, I'm going to go over these 10 thingies because one of our premises was that we don't agree on was I say all changes of climate change are beneficial to mankind. And these crazies are saying that no, it's non-beneficial. It's like the end of times, man. We're gonna have floods and droughts, and we're gonna have hurricanes and all kinds of stuff. Floods. Oh, we're just gonna all die, man. So let's see how much time we got. Or I should wait or just. Okay, I got 1 minute. All right, so I'm not gonna do that. I'm gonna be done with the video. But I will come back and talk about them 11, and then I will do the last thing of this video, which is showing you an actual overlap of CO2 and temperature for the last 650 million years, over 1 billion years. And you tell me, and what's funny, and do the same thing with what the crazies are saying, because their map of the temperatures and that is different than the regular people. But the funny thing about it is it's actually close. So I actually do think that they're both, because you can't get exact temperatures and whatever as much as they want you to believe. You know what I mean?